as mentioned, this is the second talk we're actually doing this year. We started out doing a lot of like hackathons and workshops and things, and we're kind of catching up now with the talk side of things a bit. And yeah, so I kind of reached out to Zeeshaan asking whether he's maybe keen to do a talk. He did a talk back when we were still Cape Town front-end development. Cape Town front-end developers. Back about like, what was that, like 3 years ago, he did a talk on Flexbox. And at that time, kind of we were working together, and I think maybe a year or two before that, he kind of like asked me if I'm keen to maybe mentor him a bit and so forth. So like, I'm very curious to see, obviously we don't work together anymore. So I myself am very curious to see kind of what he presents today, purely just like I always enjoy just seeing like how people have grown and progressed and so forth. But yeah, and he was only starting out with React then as well. So no pressure, Zeeshaan. This is your moment to shine. But yeah, maybe you just want to do a quick intro, want to kind of give a bit of an overview in terms of what you're doing now, where you're working at the moment, and the types of work that you do. But before I hand over to you, I just want to say quickly, what we generally do is any questions while he's speaking, maybe just post it in the text chat, and like I'll just relay it to him, or we can go through them at the end or whatever, depending on just the flow of things. So yeah, please do share any questions in the text chat as he goes. But yeah, then I am happy to hand over to Zeeshaan and let him do a bit more of a better intro than what I was managed to come up with. Yeah, so over to you. I think I also just need to give you permission to share your screen.
Yeah, please.
All right, there we go. You should be good.
Screen two. Let's do this. This is the preparation of my app. For today, let me know if you guys can see the presentation. Can you guys see on there?
Yep.
Right. So yeah, hi guys. My name is Zeeshaan. I'm a developer for about 3 years, and for about 3 years, I've had the opportunity to work with React. Now, what that means here is that for me, 3 years is very little time. So like I say, I don't know that much about React. So I'm more of a React enthusiast and trying to learn as I go. Actually, during those 3 years, I've had the opportunity to work with 3 different types of companies. I interned at Nona, I worked at OpenUp, and currently working at TouchFoundry. Funny enough, this is my last couple of days here. I'm transitioning to another company. But the last 3 places that I worked, the agency, nonprofit, company, and consultancy, basically, most of the time we've been working for projects for external clients. So sometimes it was smaller projects, sometimes it was bigger and mid-range projects. And yet, during those 3 years, I've barely come across, on my side, maybe I was just too junior to spot these, but I've barely come across like memoization techniques on the front end, right? So it's fairly new to me. So we will find them inside of the, in the React docs. So that's what basically brought me to do a talk today on React app optimization. Now, please don't question my little Giphy dog here, like who doesn't enjoy that. But whenever we're talking about React app optimization, there's multiple ways to do that. And today we're just going to focus on 3 methods. So basically the higher order components memo and the hooks useCallback and useMemo. Right, these comes with the library. Like I said, they are in the React docs, but there's very brief, explanations on what they really do. And it's only since recently that it clicked with me properly when to use those things, when it makes sense to use it. So the goal today for me is to try to relay that over to you guys, explain better through means of examples. So I try to go through some code examples with you guys. And if you have any questions, like Scott said, please feel free to ask them. And probably after each section, we can just do a couple of questions, right? So today, when we're looking at those 3 methods, what they really what we really need to first understand is the concept of memoization. I want to dig too deep into that, but just to understand the concept of memoization, what I did was the smart thing, which is to just Google what is memoization, find a definition on Google and copied it in my PowerPoint presentation. So let's have a read quickly. What it says here is memoization is an optimization technique used primarily to speed up computer programs by storing the results of expensive function calls and returning the cache result when the same inputs occur again. Now, what does that really mean? So just to give you guys an idea here, let's put it into simpler words. Whenever we are running through, we've instantiated a function, we're going to execute a function, it's going to run, and let's assume that it's going to give us some sort of result, right? The next time that we want to execute that same function, if we haven't memorized it, we will rerun the entire function again. But through memoization, what we will instead do is we will cache those results. So we will store them in memory somewhere. We keep a reference to the stored result. And if the parameters, if the arguments of that function, the inputs haven't changed, then we want to get the same output back without having to rerun that function. Only when it has changed, only when input has changed, do we rerun the function again to recalculate the new result, right? So that's basically the overall of what memoization is. Now let's apply that into React by first looking into Memo. What React.memo is, first of all, let's just go through the slides and then go through the examples. So it's a higher order component. So basically we're going to wrap components inside of the memo higher order component. It is used to memorize pure functional components. Again, using the concept of same props, same results, very functional, what do I say, like functional paradigm way of thinking. And I'm just putting this here right now. It does shallow comparison of props. To understand better what that means is when I'd rather now like just basically jump into examples. Right, let's put that into practice and show you guys what it really means to basically use that higher order component, how to memorize functional components with that. So first of all, I have right now just a basic React app where I've written my app. We can see it here, it's just my app at the moment. What I want to do, because the best scenario to explain all of this, the simplest case study would be to have a counter, right? So that's what we're going to do right now. We're going to build a counter and we're going to have a child component inside of that app component and we'll memorize it. So let's just say we have a counter. Let's start with const count set count is equal to use state. We initialize the counter with 0. Let's import use state from React quickly. We will now say, let's assume that we have like an h4, the count is right count. We will also have a button to increment that counter. So let's say unclick.
Z, sorry, can you maybe just zoom in a bit for those that have a bit smaller screens?
Is this better?
Maybe give it one more zoom.
Yeah.
Yeah, that should be good.
Sorry. So on click, we're going to basically increment counter. So let's define that constant increment counter. Already set count in here. And we're going to go per count. Count plus 1. Right. So right now we have just a simple counter. Let's have a look if it's working properly. Right, I haven't broken anything. It's the most basic app, essentially. Right. So we have a counter that's working. Now, let's imagine a scenario where we now have a child component at the bottom here. So let's define a quick, simple child components. Have that. Let's see if let's call that child.js for the sake of, when that happens. There we go. I am a child component. Right. Now let's assume that we're going to call this child in here. Let's see if my import is all right. Great. We have a child component, and inside of that child component, I would add a console.log for better understanding what's happening. Let's say child rendered. Right. So let's have a look at our example. We have our counter, and I have a simple child component here. What I want to do is open the console, show you guys what's happening. Is there a way to move those videos? Hide thumbnail videos, cool. So if I just go into the console on mount, let's refresh quickly. We can see that we have a counter and our child has been rendered here. Now, the issue that Memo is trying to solve now is what happens if we increment that counter. We will now see that child will get re-rendered over and over again as I change the state in my app.js, right? So this is proof here that child is being rendered 10 times, even though child itself hasn't changed, and there's no reason for child to change. This would be the same if whether it's accepting some props. That's what I meant here by my slide, that we're trying to memorize a function. Same props means same result. In this case, it's not taking props, but let's assume that this was taking name is equal to Zeeshaan, right? And let's assume that we're passing child into, name into child as props. We will accept it here as well. I am no longer child. My name is right. Whether we're using it here or not doesn't really matter. The idea is that I am passing a prop into my child, which ultimately this component is a function, and it's a pure function that's not changing no matter what I'm doing in the parent component. But what's happening is on increment, my count here is changing. And when this is changing, it's causing the parent component, which is app.js, to re-render. And when that's happening, it's causing the child to re-render as well. This is what we call to be basically an unnecessary re-render, right? So when I increment, this is happening over again. How do we prevent that? That's where Memo comes into play. So let's have a look at it in action. If I was just to import Memo here, higher order components, I'm going to wrap my child around Memo. What now happens is some sort of magic where, let's refresh, child has been rendered, and if I increment now, there's nothing that appears. Is that like wow enough, or I don't know? Anybody have any questions here so far?
Pretty cool, Z.
Yeah. All right, so now we've prevented some unnecessary re-rendering, right? So basically, once if props haven't changed, like I said in these slides here, slide, same props means same result. However, so what Memo is doing behind the scenes is it's keeping a reference of my child component, and it's also keeping a reference of the props that child is taking, right? So that's where it's basically checking if the previous props match the next set of props, then there's no need to re-render child. But so it does that comparison. That's where it also says that it does a shallow comparison of those props. So what does that mean that it's doing a shallow comparison? That means that's where you guys need to be careful, right? So imagine now, instead of passing name, that for some reason now we are passing an object where name is equal to dog, right? Assume for whatever reason that we are passing an object into this, right? Whether we are using it here or not doesn't really matter at this stage, right? So now what happens is, let's have a look. Our magic is now blue because the child is being re-rendered again. Now, that's basically because of the way JavaScript works, right? This is the concept of what is known as referential equality, where, just to give you guys an example, console.log here, an object equal to another object would return as falsy. So what's happening here, because each time that why this person is being re-rendered is the idea that whenever app is getting re-rendered by changing the count, we are creating a new instance of person, and that new instance of person is pointing towards a different reference in memory. That's why empty object is not equal another empty object, is not strictly equal to another empty object, right? So we can avoid that issue. It has like a method to do that. Let's, for some reason, remove name. We're going to not use that. This memo also takes in a second parameter, which can be, in my opinion, a little bit dangerous to use in some cases. So be very mindful whenever using that. This r=equal function, which is the second argument that memo takes, is basically a function that takes the preprops and next props parameters, right? And here it basically works as the should component update lifecycle method from the old React. The only difference being that here I will say if prop.name is strictly equal to next props.name, in should component update, we would return false here, if I'm not mistaken. Here, instead, we will return true. If it's true, it means that we will not re-render the child, else return false. Now, that solves our problem. So if I refresh again, child is rendered on mount. If I increment, it shouldn't appear again. Great. My heart always beats a little bit whenever I click that and I say that it will appear or it will not, and then it does the opposite. Let's get back on track. Okay, so this has solved the problem. The issue I have with r=, maybe there's something that I don't know yet on that. It's that, it's if I was to be passing name here or some function here, it would still not, and let's say that was a function as the name defines, it will still not re-render because for person, it's preprops.name will return to true, and it's a little bit of a mess. So let's give an actual example. Let's say I'm passing let ninja is equal to name. Let's say it's not even like name. Let's say it's something age 29. That's an old ninja. Let's assume we're passing ninja into this. Now, by the example that I gave you earlier, before we use that r= method, this should get re-rendered. The child should get re-rendered. However, let's see if I'm right here. However, this will not. Let's say plus ninja.age. Let's see what happens. Did I mess something up? No, it's good. All right, child re-renders, and yet you see the counter is increasing, and through the principle of referential equality, ninja is changing again. So this should change as well, but it's not doing its magic. So what I've come to realize is that like the use of, I would use r= if we're really only passing through basically one prop of a certain nature, like an object, etc., where we want to do something like this, or otherwise we'll have to take it more in depth inside of this are equal to say that, hey, if ninja dot age is equal to ninja next pops dot age as well, return true. So it becomes a little bit complicated in that scenario, and that's why I don't really like using it. Instead, I would, whenever we are passing an object over to child, which would cause child to re-render, because Memo would think, oh, this is a new object, meaning prop has changed, so let's re-render. Instead, I would rather rely on useMemo, which we're going to tackle later, than rely on R equal. But that's just for showcase, right? So let's just comment that out here. So this is basically how, let's stop passing this into it, and we can comment this line out just for reference later. This is basically Memo on my side. Do you guys have any questions? I can't see, let me see. Somebody answered, I don't know why.
So there is one question, and that is, okay, cool. Here they come streaming in. So there's a question from Vickers. What if person was instantiated with const and not let?
Const, like here. I don't think that should do any difference. I've never actually tried it, but it shouldn't, right? Okay, let's actually just use that.
Sorry, I'm a hardcore backend, so I'm just curious what that will do to the whole front end.
It's actually a very good question, because this goes into kind of some of the intricacies of constants in JavaScript, which aren't really constants in the truest sense. So for all intents and purposes, it shouldn't make a difference, because you're essentially just storing the, what do you call it? There's a word for it, but in JavaScript, you call it the reference to that object. So when you change it, when you change the object, like the reference stays the same. So yeah, that shouldn't make a difference, because constants aren't really 100% constants in JavaScript.
Yeah. So the way I like to describe it is that a constant basically prevents you from assigning it a different box, as if the object is the box. So you can't assign a different box to person, but you can change the contents within that box. So the box is still mutable.
So the irony being that if anything inside person actually changes, that it would still, if you correct me if I'm wrong, but it would actually say that nothing changed, because the reference would be the same.
Yeah, so the reference on the outer box would still be pointing to the same point in memory. And that's why the equality check would still say, hey, it's the same object that hasn't changed.
Yeah, so what a lot of people do is they kind of do JSON stringify in the memos. But obviously, within limits, if it's like stringify isn't necessarily the fastest operation, so it might actually end up being slower. But so what a lot of people do is they convert the object into a string and then just compare the objects. I know Lodash has things, and you can probably write your own helper functions that actually check for equality of actual content. But for all intents and purposes, it's just checking if it's the same object, not whether it has the same content or whether the content changed.
Yeah. So just like to rather prevent this, like let and const here, like what they're saying, doesn't make a difference, right? So I've already removed that R equal, and we're memoizing it. So we've seen that here, it will get re-rendered over again. How we could avoid that is in this particular case, because it's a small, instead of having it here, we could just literally define it outside of app. In my opinion, this should basically prevent re-render. Let's have a look. All right, refresh. Oh, I've just said something without testing. Yeah, okay. Our report. So it stops, it doesn't re-render. The reason here is because here we are pointing towards the same person. Like we don't have multiple instances of person in memory here, right? We don't have multiple references of person in memory. While whenever we're defining it inside of app.js, when it's getting re-rendered, we're recreating a new person in memory. And that's what's causing, you know, basically the referential equality to fail, that check to fail. So if we can just put it outside, but very often in many apps, maybe this person is only coming in as props. So we don't have the ability to just define it outside of the app itself and to prevent, to get it outside of that render, you know, cycle, so to say. Does that make sense?
Yeah, it does for me. And I think it speaks to kind of what we just mentioned in terms of it's not checking whether the content of the object is the same, because you're essentially creating a new object every time that component runs. It would say this is a different object from the last time the component ran. And, you know, yeah, regardless of whether they have the exact same content or not. You know, this is one of the things that trip people up. This is a JavaScript thing and not necessarily a React thing. But yeah, it makes a lot of sense.
So now, is there other questions, by the way?
So there is a question, and that is, why is the React.memo higher order component behavior not always applied to child React components?
Style.
So like, so Kifi, maybe you can expand on that, but I think my reading of that question is, why isn't this just the default behavior?
Oh, yeah, I don't like the default behavior, like in my opinion, right? Right now we are adding an extra step. Basically, we are caching this child component. So even though it's looking great in that console that I'm just showing you guys, we are somehow reducing, we are increasing our initial render time, right? So now instead of just rendering child, we are also caching it. We're keeping a reference of child in memory. We're keeping a reference of the props that it's taking in memory. So if we just use that for anything, we could end up slowing our app whenever it's not needed. So just to give you an idea, right? So let's imagine instead of count, instead of person, we were passing count in here, right? And instead of person here, I'm using count. It's memoized. My name is just a number now, right? So this here is like, if by default, in my opinion, if by default it was just memoized, this will make our app much slower, because even though we are using the memo right now, we need the child to re-render all the time, because you know this is changing here as well. So we've added an extra step for basically nothing. So yeah, so I think that's why it's better to have control over these things and to think really well when to use it. Does that somehow answer the question?
Yeah,
so
I think that's a good explanation.
Yeah, so like my general, so I get asked this quite a bit as well, like, why isn't this just built into React? And my response is usually that, you know, like React, like, so there's two parts. There's the actual rendering and there's the actual creating of the tree and comparing the tree, which is kind of the virtual DOM side of things. And React is really good at like diffing the virtual DOM, you know, like that is like where most of the engineering effort goes. So React is really good in building up a DOM, diffing it against the previous DOM and so forth. So that doesn't necessarily mean it's going to get re-rendered. So sometimes you just want to let React do its React thing. And it might be faster for it to just build the component, diff it, see if it needs to change in the DOM. If it says no, then just continue, instead of actually running like checks on the actual equality of props and so forth, especially if you're passing in like objects as props. You know, then it's going to take a lot longer to do that diffing, instead of just building the damn thing and and then actually just comparing it to the previous thing. Yeah, but then like he kind of follows up with another question. Yeah, he's going to give you lots of like tough questions tonight, but this is good.
When I'm in this mode.
Yeah, so he asks if memoization can result in a memory leak.
I don't know what, like, I haven't gone deep into that. I just know that you are basically trading time for memory here. So you're slowing your initial render, but the idea here is to have your re-renders, much faster. I don't know what could go wrong in terms of memory leaks. I'm not an expert in that at all. So I don't want to give any fake answers or made up answers here.
So I'm wondering, Kif, is that a rhetorical question? So I think my guess is that if there was a memory leak, that means it would still do the equality check after the component unmounted. Is that kind of like how you're foreseeing there possibly being a memory leak?
So I suppose the question comes down to more like how often is the component going to render? Because if it's going to be rendering many times with different sets of props, obviously it has to re-render for each one of those. Does it just keep track of the current most recent render? Or does it actually remember what I rendered 5 renders ago with the different sets of props? And when do they essentially say, okay, we're going to discard this result essentially with those sets of props? Is there some sort of time to live that they've built in or not? I mean, it's very, very detailed.
Yeah, I haven't actually looked into that. Or I think that what's happening is that it's basically, storing that lost result, that lost computed value, that lost cache result, not necessarily the last 5 results. So I think each time that it changes, it will, get rid of the previous stored value and keep the new one. But don't take my word on that.
I don't know enough about React internals to actually speak to that. But I guess to me, it would maybe be, I think you can maybe, yeah, I can't actually, no, I can't actually see how that would happen, but I haven't spent enough time thinking about it. I'm trying to think of ways that you can accidentally create a memory leak. I don't know, like that's why I asked Kif if this was a rhetorical question, whether you knew the answer to this.
No, I don't know, but I think it makes sense that they would just keep track of the most recent one, because we're not trying to store history. We're just trying to know whether we need to re-render the current one or not.
Yeah. But but I think that's also something that maybe adds to your your internal conversation you need to have, whether you want to memoize is that like it is now tracking something in memory that it wasn't before. So I think that's also part of the conversation. So there's a question from Moose. It says, would you say that an ideal is to build the component first, then see where you can apply memoization to improve performance?
Yeah, absolutely. I think that's one of my latest slides. Next is like to just, it speaks to what you spoke about earlier, Scott, about like how React is incredibly fast as it is when it's use of the virtual DOM, right? The child is being re-rendered, but it's not being changed. It's not being repainted entirely on the screen. It's just, the console's running, functions are running. It's already as fast as is. There's better use of time as a developer to make it work, make it pretty, and then make it fast. Right, that's a concept that I've taken since the time of OpenUp. So yes, definitely. Like this is really a step that I would take only when I get a chance to like come back to certain features and see if there's a way to make them better. Cool.
So I think that's all in terms of questions. So you're free to go ahead with your 29-year-old ninja.
Nice. I should have used the ninja instead of person. I was tempted to, but in any case, okay. So now that we've tackled memo, now let's imagine the scenario where we have now a function. Let's say we are change name, right? And that's a function. Let's assume that we are setting state here. Set name. Let's say the person was part of state. In this particular case, we're just going to console log new name. Right. So if we now have the situation where we have to pass a function into our child component, which we know that it's being memoized, right? Using just a normal memo. It's using. Are we still using count? Let's change that to using name again, just to make my name a little bit cooler, instead of count. Oh, yeah, and the count was really for that particular scenario. Okay, cool. So we are passing name. We know that it should be memoized. It won't get re-rendered unnecessarily. But what if we're now passing a function? This is basically referential equality checks again, right? So now child should get re-rendered over and over again. Because the same as an object, the first instance of a function is not strictly equal to its next instance. So that's where now we come into useCallback. So let's have a look at that slide. useCallback is basically a React hook. The purpose of useCallback is to memorize a function or like a callback. So it returns to you a memorized callback. So it returns the same function instance for the same dependencies. Basically, it takes an array of dependencies where you will tell it when to rerun the function. Again, for these dependencies, it will be a shallow comparison of the dependencies. So be very careful there when you're doing that. So let's have a look at that one. It should be super quick. Let's put that into action. So again, we import useCallback from React. We have our change name function. Let's say now, cache change name function is equal to useCallback. This is how we use it, right? It basically takes a function as the first parameter and a dependency array as the second parameter. In this particular case, I'm not putting anything in there. Maybe you want this function to change whenever something changes. Maybe something is a parameter of change name. Usually, very often, the dependencies will match with the parameters of that function. In this case, we don't have anything, so we're going to leave it empty. Here, I'm basically saying, please cache my change name function, and you don't have to rerun it ever again. We're always going to just reuse that. Right now, instead of passing the change name into it, we're going to pass the cache change name in here, right? Again, it doesn't matter whether we're using it or not. It's more about the principle of passing, but let's, we could be using it like that. It doesn't make sense to use it like this, so I'll remove it. So now if we have a look at what happens inside of, our mini React app, hopefully now child shouldn't get re-rendered past the mount. So let's do that. Boom, here we go, and that works. Right, so useCallback is, in this case, like that was probably my fastest and quickest slide. When would I use that? I was thinking if I want to bring that up next at the end or later. But yes, so whenever you have to do some referential equality check, whenever you want to basically, check whether a previous function versus a next function versus the next instance of that same function is the same, for example, that's when you would use callback. Any questions on that part?
So there's a pretty good question from Maureen asking, can you use memo on a component without checking anything? Just like saying this should never re-render ever.
Memo like this.
Mm.
Yeah, well, I mean, that's what I said. Like we did it initially when we weren't even passing any props. you know, and we just basically memorized it. But that's what I was saying, that think well before you do that, right? If you know very clearly that this is the most pure component ever that you have, it's purely functional, it's never going to change, it doesn't have anything within that needs to rerun, then sure, go ahead and memorize it. And you don't have to do any of these checks. But if you're passing a function into it, like I said, that's going to mess it up, because even though it's memorized, we saw that it would get re-rendered over again, and that's because the change name itself wasn't memorized.
So then there's another question around when should you use callback? What are good use cases? Yeah.
Imagine this. That's the thing. Like, this is a very weird example. Yeah, like first of all, imagine that you are setting state in your parent component and you're passing that to your child, right? So this here, instead of, you know, let's say that, you know, we had some sort of like, you know, cons state something, ninja name, and set ninja name here, right? So we had something like that, use state. So let's say, you know, Zeeshaan star, right? Not bad, this one, eh? So we could basically, we have a function here that allows us to do that. But actually in this case, I wouldn't, because it's not that expensive of something. First of all, I would really, you know, use callback when there's an expensive function running. We're doing something that's super important. So instead, actually forget that example. I would rather do it whenever, let's imagine that, you know, for example's sake, we have a use effect that's running, right? We are doing whatever, some API call here. And for some reason that we want that to rerun whenever this function there, or, you know, whenever this function changes for some reason. So then I'll do change name here. Change name, however, even right now, it will, my IDE will give me like a little thingy that will say, hey, wrap this inside of its own use callback, because it will think here that change name is changing all the time. So it will run that effect all the time, rather memorize it first. But again, I would do it for whenever the purpose, instead of change name here, would be a more expensive function where we're doing some complicated things inside of it. Expensive calcs here. This should break. Does that make sense? I don't know, do you guys have some better examples?
That's how I mostly use them as well, is to just prevent use effects from firing unnecessarily.
Yeah, you see, that's like, before I was like, oh, how do I do this? Then, or if it was an object inside, then I would do some conditions, etc. But now, hey, we have memo, use callback, and now we're going to move towards the next slide, which is my next point of view. We've already covered that. Use memo. So what is use memo? It's very similar to a use callback, right? It's also a React hook, extremely similar to use callback, but instead of memorizing a function now, we're going to memorize a value. And that's really any value types. Like, you know, that's what I would do to memorize that object person that we did before. And basically, because it takes any value type, we can also memorize the functions with use memo and use it as a use callback. But I don't know why you would do that when there's use callback already to memorize functions. It also takes in a dependency array, works similarly, and it has, you know, it does shadow comparisons of the dependencies. So let's give that a visual, you know, example. I hope you guys are enjoying the like visual examples, and that helps in explaining the value of it. imagine a scenario where we have numbers list, set numbers list, you state, right? Imagine that this is a super long array. Here it's going to be very short, you know, because I'm not going to make something super complicated, right? But imagine that this is a super big array that we have in our state. And imagine we're now going to forget about the chart. Imagine that we're doing some expensive calculation, right, with that array. Our expensive calculation is going to be max value of this array. Max. We're going to spread, what did we call that? Numbers list into this, and we're going to return max value. Right. Imagine that it is super expensive. Some crazy, you know, data manipulation happening there. Imagine it's for some graphs. You know, that's an example that's coming to mind because, like, we're working with graphs at work right now, and I can see where we could use that. Basically, you know, you will have random sets of data, really big sets of data that you have to like manipulate, memorize. Would be a great, I mean, it would be a great time to memorize these, especially if the inputs haven't changed, and only recalculate those things whenever, you know, the graphs is changing, the inputs are changing. So let's imagine that we're going to leave child out here for a minute, and we're going to say h4 again. The max value is, we execute that, right? So we're executing that to get basically the max value. Let's add a console.log here to say expensive calculation are happening. Right, so let's do that. Now let's go into our app again. Or did I minimize that? I did. Refresh. Let's have a look at what's happening. So on initial render, we've calculated, you know, the expensive value. So 100 is what's coming out. And now, again, when our parent state is changing, we're going to end up recalculating that expensive calculation over and over again, even though the array itself hasn't changed, right? So this is basically, again, unnecessary, you know, processing that's happening in the background just to get 100 over and over again, and the value is never changing because our array is not changing. So that's where UseMemo comes now into play. UseMemo is to memorize a value. So let's do that. UseMemo. Where is our expensive calculation? So let's imagine that cached max value. Bear in mind, you know, I'm naming it as a variable now instead of, you know, a function. Now I will use UseMemo. Oh, how did I? Ah, there we go. I'll pass. Where's my bracket? Let's see if I'm doing that right. I'll pass a dependency array here, and here my dependency array will be basically numbers list, because whenever numbers list changes, then I want to basically recompute that max value. And now instead of, you know, executing this function here, instead I will just render my cached max value. Let's see what happens if we're going to see this expensive calc happening over and over again. Right, so if I refresh, please work, expensive calc happening on mount. If I increment, yeah, I'm good. Just like sulfide. Okay, cool. So now we're not recalculating that max value. We could also, however, use it the same way as, you know, like I said, like use callback, which I don't necessarily advise. If we had to use it like a use callback, then, you know, I would call it cached expensive calc use memo, just for example's sake, where I'll pass him I'll pass this in. And now basically I am now pass that in here. Right now, I am now basically memoizing the function instead of the output of that function. So to see this, then instead here, I will have to go cache expensive calc and execute it. If I'm not mistaken, let's see if I didn't break the app. I did break it. No, didn't break it. And that should also work. Oh, doesn't it happen? What did I do wrong here? I think I'm supposed to not execute it here or put it here, right? Something like that. Wow, why are you doing that? Yeah, okay, I executed it the wrong way, blah, blah, blah. So then that now is working like, you know, a use callback. Again, I don't see the value of doing that. That's why use callback exists instead of this. Yeah, so I'll take that out and put this back here. Now, again, where this is not beautiful is if we come back to, let me, you know, just import use effect, just to show you a proper use case of when to use that. You know, imagine now in here that we were passing person as well, right? Already the IDE is giving me that little, you know, warning thingy. The person object makes the dependencies of use effect hook change on every render. That's normal because now it's thinking that object is always changing on every render because it's pointing towards a new reference in memory the whole time. So then it's going to make that API call on every render. To move it inside the use effect to define it once, or wrap it inside of its own use memo. So we could do something like, I think we even have to like move it top, something like that. Const memoized person within the use memo, right? Where we're going to just do this. Is that correct? And instead of passing person here, I would pass memoized person, and we don't have this thing happening here. Why is this? Oh, this was used before it was defined. Need to move this up there, which is a thing. It's just for that one example. Let's see. Something like that. Again, let's move this. It's just because, yeah, it's just the order that I'm doing the example. So here would be another use case of wherever I'm going to use that memorize, that use memo example. What I was doing before was I would put person here, right? And then I would say inside, hey, if person.name is not equal to, let's say person was, you know, initialized as an empty object first, I would say if person.name is true, because I know that it has not changed, but that doesn't solve the issue at all. Like that causes a whole bunch of other issues that doesn't work the right way. That's why we would then memorize that object to make sure that these dependency array, I think Moose asked me that once, like, you know, because it does shallow comparisons here, it becomes very complex whenever we're using, you know, objects as part of our dependency array. And that's where useMemo comes into play. Any questions?
So I have one. Might be a bit unfair, but I'm going to throw it your way. So Dan Abramoff once said that useMemo. Sorry?
Anything that starts with like Dan Abramoff.
Exactly. So brace yourself. So he said, to quote him directly, use memo is a hint, not a guarantee. Are you able to speak to that? Like, what does he mean by that?
So what I've seen is it also appears in like the React docs that like they might, you know, actually, can I just like because it said in the React doc something about what you just spoke about, that it might not be the case in the future, and it might not always, I can't remember if it said if it might not always memorize it, but rather that the idea that they wanted to use here is that your app should work, you know, without the use of UseMemo, the same way that, you know, whether it's memoized or not, it should work the same way without the memoization techniques in there. I don't know if they want to keep that as a thing. I can't speak much more about it. Actually, I can't speak at all about it. But yeah, I've seen that in the docs as well, and I'm not sure what they have in mind about that.
So my understanding is that, so you get other memoization like libraries, like a pretty well-known one is, I think it's called Memoization 1, which guarantees memoization. So no matter what happens, it's always gonna like do memoization. Cool, cheers, Vickers. With React, React might decide to disregard that. So because React is storing and this maybe speaks to the conversation we had previously about kind of memory leaks and so forth. Because React stores that in memory, there might be a point where React can be more performant by clearing that from memory. It's not going to hold on to that value as a guarantee, as a 100% rule. Like there are circumstances where it's going to decide for whatever internal React logic that it's going to get rid of that memory allocation. So yeah, so that is just the thing, and that's why you would rather use React memoization over like an external memoization like library, unless you really need to be 100% sure about the fact that it's going to get memoized. But yeah, as I also mentioned previously, React is really, really good at kind of like figuring things out for itself. Like it's gonna like React is built by some of the smartest people in the industry, and like you're gonna have a very hard time manually building something that's going to be more performant than kind of what they came up with. So sometimes it just uses its own kind of gut and it says like, yeah, I think I'm going to get rid of this memory allocation or whatever. And I'm also happy to kind of refer that to the React internals in however way it does that. But yeah, so that's just the thing. So, and I think you raised an important point insofar that you shouldn't rely on memoization. If your app is going to break if memoization doesn't happen, that's a problem.
Its only purpose is for a performance boost.
Exactly, exactly. So don't build any functionality on top of that principle. It's just a nice to have that, you know, it's going to run in the majority of cases. Yeah.
Cool. Can I move on to the next one?
So there was a question around callback, but that has mostly been answered in the chat by other people. So Kifi has another question around if I create a custom hook, should I use callback and use memo inside the custom hook?
You know, this is going to be very hard to imagine that use case. Like in my mind, like it basically answers to that question from before, right? Don't build to just memorize things. Like don't have those concerns in mind before you've even built it, right? Like if I'm building a custom hook, I'm building a custom hook without any memorization techniques involved in it. I'm building it to make it work the way I want it to. You know, tomorrow if you find that, you know, your custom hook is doing some, you know, causing some re-render of some unnecessary re-render of some child components somewhere, or, you know, causing a function to rerun, then look into memorizing that. But, you know, like right now, by you even just saying that, like, I'm not thinking of an example for that use case.
Geez, yeah, that's such a great answer. Is like you shouldn't actually even talk about these things in the abstract. Like, you know, like don't solve problems that haven't emerged just yet.
Exactly.
You know what? What's that?
Like,
what's that?
this is very specific.
It's a, you know, about premature optimization being the root of all evil. Yeah. All right. But yeah. So that is all the questions at the moment.
Right. So at this stage, we've talked about, you know, memo, use callback, and use memo, and how we can make things so much better. And I wish I could just tell you guys to, you know, go forth and conquer. Like I said, like, you know, just go and memorize it all. It's just not happening. You guys are even asking me that question right now. So we've looked at, you know, the good sides of memorization, but to really understand when to use it, first let's understand the drawbacks. Like, you know, on a high level, the drawbacks of you know, applying these techniques, because I don't want you guys to just go out there and just memorize every child that there is. You know, like I said, there are examples where you're just slowing down your app instead of speeding it up. How so? First, a drawback, it's adding an extra processing step here, right? So we are now doing a caching step that we were never doing before, right? So that's why our initial render has now slowed down. So if we measure that, we will see actually, you know, if we have time later, we can have a look at, I think React now has that profiler import that allows us to look into the actual time that it takes to render a mount on re-render. So we can have a look into that a bit later if we have enough time. But we are now adding an extra step. An extra step means it will take, whether it's like 2 milliseconds extra, you know, it might not be visible to the naked eye, especially not with examples that I've given where, you know, I'm telling you guys to use your imagination to imagine something expensive happening, but we're doing something very simple. So we're not really seeing the benefits of it. But if it's really expensive, then it takes some time. You know, we are also caching the actual output, the actual function, the actual child, etc. So again, we're decreasing initial render. Number two, it adds complexity to the code. One example is that dependency array. What I mean is that this is the point where now we have to be extremely vigilant of, you know, when we want our memoized function to rerun. Again, in the examples that I've shown you, there was the first one for the use callback, my dependency array was empty. In the second one, there was only one dependency in that. But imagine if there was like, if your function is taking a couple of arguments, maybe 5, 6 arguments, which is, you know, that's a lot for a function to take like 5, 6 arguments. But imagine that you haven't put all 6 of them inside of your dependency array. You've you've accidentally left one of these out. Suddenly now your function is not going to rerun whenever that dependency has changed, because you haven't, you know, told React to, hey, rerun this when, you know, that missing dependency changes. So you now need to be way more vigilant on that level. Third point is, the third point, like, you know, high level that I want to talk about is that now we are basically trading time for memory. Remember, we are not just memorizing the child, which ultimately is a function, right? We are not just memorizing the function, the values, but we are also keeping a reference of the dependencies that we are providing it into memory. So, you know, so that on next re-renders, on following renders, we're going to speed up the process. But on initial render, we are going to slow it down. So there's that trade that we're making, and we need to be extremely aware of when to, you know, when to really just optimize, not just like, oh, I've seen this technique, let's just use it. There are times for it, right? So in that scenario, when to really memorize stuff in your app, in your day-to-day app. Not everybody's building Facebook, Instagram, you know, Uber, this and that. In our day-to-day app as developers, when to really memorize, like first when we see opportunities to avoid unnecessary re-render, right? That's a good opportunity. With the child, we can think, hey, can we memorize that child or not? You know, we might have, this parent component and some child that's only rendering text in there. We could potentially memorize that, but think again, is this really going to harm me if I don't memorize it? Or is it just going to take me 1 millisecond to just re-render the chart? And if that's the case, that's okay to not memorize it. When to really memorize? When there are like computationally expensive, calculations happening, like functions where you're doing heavy data manipulations. I think that's a great use case. Again, like in my mind, I'm thinking the graphs at work that I'm working on, those would be great use cases to use principles of memorization. But again, I wouldn't just do it on my first go. And that's, that's going to be my last slide. So we'll just keep that for a little bit later. And when to memorize again is, when there's, issues that's being caused because JavaScript is JavaScript, because of the referential equality checks, like in that use effect scenario where one of our dependencies is an object. For example, that could be a great case to memorize that object so that, our use effect doesn't re-render all the time. So that's when I would say, when to memorize. But to basically go into my final slide here, having understood all of that, again, most of us developers are working in an agile. Very often we're working in an agile environment. Very often we're working towards MVP, right? Minimum viable product. We're trying to get something out there. There's no reason to optimize something that you just created that one user is going to use, but it's taking 1 second and I want it to use 0.8 seconds. You're not winning on anything by doing that. So this, like I said that earlier before, a concept that I want to end with that, the concept that I took from OpenUp, from working with people like Scott and JD, is first of all, it goes like, make it work, make it pretty, make it fast, right? Get your MVP out there, make it work, make it pretty. That second step, I've almost kind of put together with my first step of making it work and making it pretty. Focus on your naming conventions. Focus on, will another developer understand what you're writing here? Forget about another developer. Will you understand what you wrote there? 3 months later, let X is equal to 10. What is X? It's rather use that time to say, hey, let number of days equal to 10. So that 3 months later, when I come back to that code, I know exactly what's happening. Make sure that the indentations are correct. Use linting. I plead guilty on that I don't just, put linting as the first thing as a set of a project, which is absolutely, I'm changing that. But, set those things up. And in an MVP environment, in an agile environment, sometimes we don't have time to just come back to optimizing features only immediately. Instead, we need to focus on the next feature and the next feature. And later down the line, when we have a chance, or that we're seeing, oh, we have so many users and this component here, this particular feature is taking long to load. That's the opportunity then to go and measure what's happening in this particular part of your app. See, and even then think of how we could optimize it, but also first measure it, see, what's really not working and what's working. To give you guys a quick, idea, like we have the React dev tools, we have the profiler there. So, but also just like, just to end on that note, let's wrap our entire app for this case, right? Let's wrap our entire app inside of profiler. This is just for example cases. I am by no means trying to go deep into this or answer questions about profiler. That is not the intention here, please. But so this will take an onRender function. So let's call that render callback, whatever. Right. Callback. This takes a couple of arguments. The first 4 are basically the ID, phase, actual time, base time. Right, and there's a couple more arguments that it takes, but for this case, we don't need more than that. So basically, profiler is this component that you can wrap around any part of your JSX to basically measure, you know, actual time versus base time. So actual time is how much time did it actually take to render, and base time is how long would it have taken to render without memoization techniques involved, right? So in this case, all I'm going to do in here is console log, right? I'm going to do a couple of console logs just so you guys see the phase that we're in, which is, you know, mount, update, etc. I'm going to do that for 3 more. So actual time. Have a look at base time. And let's do performance. So now let's see if my math is right. So we can do base time minus actual time divide by base time, right? Yeah. We will multiply that, multiply by 100. And let's put that all in like percentage, so we can just go like, you know, percentage. If I'm not mistaken, this is a very long. Let's see if that's working first. All right. That's just a quick idea of. So we are wrapping our entire app, and yeah, it's working great. This takes a long, so let's just add 2 fix to this whole thing. I think we can just do 2, yeah, and make that 2 decimal places, so it's easier to read. Great. Let me refresh. Let me restart. Right. So actual time that it took to load this whole thing is 7 seconds here. Right. Based on without any of these memorization, look by how much we've actually, in this particular case, slowed down initial render. But what happens if I increment? Oh, now our performance boost went to 7.7. Now it went to 88.5%. Right, so we are increasing, you know, the update phase, but initial amount has been decreased by, in this case, 196%. Right, so even like, you know, forget about the profiler. What if we use React Dev Tools, the profiler from here, load and start profiling, right? Stop. Cool. We can see how long it's taking to render which part of our app. Now, let's say I want to start profiling again and increment. Maybe stop profiling. Ah, look at that. The child did not re-render. That's great and everything, you know, but again, measure properly, look at the time, see what's really happening. And there are better measuring techniques out there that I am not, you know, maybe that's another topic. Maybe I could learn more about that and share that with you guys. But I'm not that person to speak more on that right now. But yeah, so again, just to leave you guys with that, put it in your mind. I'm very, like, I follow that concept as much as I can. Make it work, make it pretty. Only then do you make it fast. And that's me.
Cool. Thanks so much, my man. Like, we actually paraphrased it a bit. It's actually, I think technically it's make it work, make it right, make it fast. The right being kind of like following the correct like principles in terms of programming and like not having hacks and so forth. But yeah, I think we just. Yeah, I think we just paraphrased it as pretty, and that kind of just stuck. But the principle stays the same.
Since my junior time, dude, like that was what, like 2019, beginning of 2019, something like that, right?
Yeah.
Like my beginning journey.
Yeah.
With you
I'm
guys.
glad that stuck though.
yeah. I've taken a couple of things from different companies. This is what I've taken to you guys.
Yeah. You're blowing some minds with that profiler. Yeah, really? I'm glad you included that.
Oh, snap. I was like, I thought I went above time or something. I didn't know. But yeah, this, you know, performance boost. Look at that. Look at this. and it doesn't guarantee actually that the next time it's going to be faster. That doesn't guarantee it. Like, you know, see, it's now 70%. So yeah, I think before we use those techniques, first, let's leave React to do whatever it does best, right? And only after that, like, there's more research, more understanding before you start diving into these. But it's worth still knowing these techniques, which was completely, you know, new to me. I only learned about these a couple of months ago. When I shared it with Moose and Caitlin, they also barely knew about it. Like, I think Moose somehow was aware of it and, you know, hopefully gained value from it the last time. Caitlin gained value from it, and hopefully they gain more value from it today as well, and other people as well.
I would love for someone to do a talk on DevTools. But yeah, like, so if anyone wants to volunteer to do a talk on DevTools, by all means. I see there are actually some hands raised. I'm only seeing them now for the first time. Sorry if they've been up for a while. Moose, I see. Do you have a question?
Oh, sorry. I thought that was like a Skype thing for, you know, like when you can do the whole like emoji thing to like say, well done.
Oh, it's a high five. It's not a raised hand, it's a high five. Well,
okay.
Yeah, so like, well done, Z.
And also, just to, like, you know, clear it out, just a quick fix here. Where is it? Oh, yeah. Remove it. Okay. Make it right.
Well, you made it work. So
yeah.
You're only getting to the make it right part now.
Exactly. And use that concept, and it's great. Thank you. I just saw that in the comments. Somebody said it as well. Yeah, I actually led it to you guys, not through an actual code somewhere. So it's actually interesting that,
Yeah, it is. It's Kent Beck. But yeah, like I stand corrected. It is make it right. But yeah, so next steps, make it fast. So the next time you're going to do this talk, it's going to be like, cool.
Any questions? Any, like, you know, you guys, did anybody gain value from it? Just maybe from some feedback.
I have a question.
Yeah.
Go ahead.
So my question is, let's say I have a common component that's used in different pages. So one's used on the home page, one's used on the About Us page. If I memo a component, will that make my subsequent speed for, like, let's say I log on to the About, or I click on the home page, and then I decide to go to the About Us page, would that make my speeds faster or my performance any better?
No, I don't know. I think that's where you need to go and actually, you know, try that profiler thing. Like, I haven't tested that. Like, that is a super cool question. I don't know. I hope you get a performance boost on that, but no, I'm not sure.
So yeah, so I think, I guess my response to that would be is that I often find, so to me, there's a positive correlation between like the amount of what would be the word, like the distance a change needs to travel up the tree, and how valuable it would be to kind of memorize things. So where I sometimes do use it is, if I have like an input component, or like some type of input or free text or text field or something, and I need to lift the state quite the way up, because it maybe needs to be used like somewhere like high up in the state. Like maybe it needs to do, a good one is usually something like search, you know, so you have your actual search component that is kind kind of handling its own state, and and it's kind of very deeply nested within an interface. But the actual information related to that search component, that text search, needs to travel quite high up in the tree because it might influence other things on the page besides just its own little space in the interface. So that is a case where that means that every letter you type, it's going to re-evaluate the entire page. So that means you very much get into a space where you have a massive delay as you're typing, because something that's meant to be instantaneous now has to re-render the entire, not re-render, re-evaluate the entire page every time. So to me, in those cases, memoization is very helpful. So my guess is then, if we're talking about kind of changing pages, that's generally, it's probably wiping the entire tree and rebuilding an entirely new tree. I stand to be corrected if I'm wrong. So my guess is you're probably not getting a lot of benefit over there. I think, to me, you get more benefit in terms of if you need to change a very small thing in the tree that needs to travel up quite high in a very nested page. Yeah, I'm curious to hear anyone's thoughts on that. Possibly. So Nathan is asking about code splitting. I can't speak to that specifically because I generally tend to do very Jamstack projects. So my code is usually split by means of just actually different static assets and in HTML pages and so forth. So I don't necessarily do code splitting in that way. I don't know if anyone can maybe speak to the effect code splitting has. Yeah, so Stuart is asking about loadable and code splitting and so forth. Yeah, my understanding is that suspense is a lot further out than we maybe thought. So yeah, loadable is probably your best option. And from what I've seen, I need to be careful what I'm saying now, but it seems that suspense is definitely gearing up to be the next web components, insofar that it's something that was meant to change the world, and it's turning out to be very underwhelming. But once again, yeah, send all hate mail to all the suspense fans. But yeah, any other questions?
Thank you.
Yeah, it was phenomenal, really well done, dude. And I'm not just saying this to be polite and so forth. It was a phenomenal talk.
Yeah, I was a little bit nervous that this might be, I don't know, too generic or something like that.
The beginning of the end of your career.
Yeah, the beginning of the end, and also at the very beginning, you go oh, I'm keen to see where he has gone. I'm oh, you're putting so much more pressure right now. I hope you're pleased. And yeah, and I see a lot of people are going on about the profiler thing as well. Yeah, that's a nice thing to go and play with.
So I see Nathan has a question about unit testing, memoization.
Yeah.
Yeah.
Sure. No. I don't want to answer that at all. On my side,
me neither, because
that's been my weakness, and that's literally where I need to now step up into better unit testing. That's my nightmare,
So that's the other talk in 3 years.
Yeah, I would actually have to really step up on that for the next couple of weeks now. So hopefully I gain something and maybe do another talk, or maybe somebody else does the talk, and I would definitely attend that.
Yeah, for me, I've over the years, and I don't know whether this is just that storybook has become like more and more powerful, but I've come to rely on unit testing less and less and less over the years. I don't know, like I maybe I'm just not building the right kind of React apps, but yeah, I'm not necessarily getting the return on investment in terms of opportunity cost, in terms of writing unit tests. And yeah, like I think like, for example, something like a snapshot test is very easy to write, but give that like 3 years or 4 years and you'll need like a quad core PC just to run your tests. So yeah, I don't know, like I still like a bit torn into about unit tests, specifically React unit tests, but yeah, so I can't really speak to that either.
Cool. Then
so that seems like it's about it. So yeah, thanks so much, my man. So next month, let me just check. So we have something lined up for next month. It hasn't been published yet. We'll probably publish it this week, and I think it might be. Yeah, so we're going to do, so obviously May 5th, we're going to do a live Q&A with Miriam Zeeshaan, like who's one of like my personal, like she's probably like my most influential like person within the CSS world. It's going to be really interesting because she also played a very big role in kind of the release of the container query specification that just came out. So yeah, there's going to be some really interesting discussion there. So that is on the 5th of May. So you guys can have a look at our meetup page if you're interested in joining that. Then we also, not this weekend, the weekend after that, we are partnering with Ubuntu Beds and She Can Do. And so She Can Do is kind of a couple of ladies within the kind of world of like UX and product design and so forth. They also run a meetup, a very successful meetup in Johannesburg. And so we are going to do a hackathon for healthcare, kind of looking how tech skills can be used to kind of help kind of healthcare workers and so forth during COVID. And then the next talk is, let me just have a quick look here. Oh, so Justin and I are going to do a talk on web accessibility for Global Accessibility Day, which is in May somewhere. And we're specifically going to talk about web accessibility for designers, because I think that's not something that's like kind of discussed quite enough. There's a lot of material in terms of ARIA labels and how to like do accessible button and so forth. There's not that many resources for designers who actually create the interfaces that we need to build, because a lot of times we are kind of just like following what they've created. So that is then a talk that Justin and I are going to tag team. But yeah, otherwise, just keep our meetup page, kind of have a look at that, seeing anything that comes up. We are also going to be possibly this month already doing our first podcast, in which we are going to chat with Amo and Leandri, who's here in the call as well, just chatting about like how do you get into the world of front-end development, someone who's kind of very new to the industry and so forth. Yeah, and then otherwise I will keep you guys updated on ZA Tech and so forth on anything that's happening. And I will probably upload this video tomorrow and then share it with you guys, and then Zeeshaan can send it out on LinkedIn to all of his contacts for that extreme status points. Mr. Big Shot. No, it was a phenomenal talk. Like, really well done, dude. I'm super proud. Yeah. All right. Cool. All right, everyone. Have a really great.
Where can we find?
Ah, yeah. So, good question, Stuart. Well, or Nathan, I guess. So, Zeeshaan, where can we find you? Where can we follow you? Where can we give you money?
If you want to give me money, I'll share my bank details.
Okay, so anyone who wants to give Zeeshaan money, they can redirect it to me instead.
Yeah, so Slack is where, like, you usually, like, Slack Zeditech is where you would find me on the Zeeshaan, or otherwise just like on my LinkedIn. Maybe, you know, like, I'm very friendly, like, I accept people's you know, connections on LinkedIn very easily. If you want to have a chat or whatever, then we can take it you know, in a more informal setting afterwards. Right, let me just like put that in. I don't know if anybody wants to like follow me, connect, and we can have chats, or just like find me on Zeditech. You know, it's already informal there, and yeah, I'd be happy to connect and talk more.
Cool. And also, please send all the money meant for him to me.
Part of it will go to the non-profit here.
Yeah. All right. All right, guys. Have a great evening. We'll chat soon. So hopefully some of you will join us next weekend. But otherwise, we'll chat again next month then. Cool. Cheers, everyone.
Cheers.
Thanks.
Bye.
Cheers.
Bye.